Okay, so now we are going to move on to the properties of soil. So um, let's look at this picture right here together. So this shows us the different layers that soil is found in. Now, we don't call them layers because we have to be fancy. We call them horizons. So this right here is what we call a soil profile. So every horizon has a specific set of conditions or components, and it basically varies by the amount of organic content that is found there and how much of that parent material is in that specific horizon. So as soil develops, layers, it's supposed to be a comma, layers form, and remember we are calling them horizons. Now, you guys do not need to know the specific horizons, but you do need to know that there are different horizons and they contain different components, and it usually varies by the amount of organic material. So, organic material and minerals move through these layers. Now, they can't move through all of them because at a certain depth, the soil becomes very hard and dense and almost like the parent material. But for a certain amount, it can move through the layers. So we call that translocation. Okay, so translocation explains how materials are moved through a soil profile. Okay. So when we look at this, we know that going down, we're going to have decreasing organic matter. You're going to have more organic matter at the top because that's where most of the life is going to be. Okay, so decreasing organic matter. Now, organic matter, when we're referring to soil, is called, I know this looks like hummus, but it's not, it's humus. It is, hummus is stuff that you eat. If you know, it's a dip type stuff you buy at the grocery store and you eat it. That's not the same thing. This is humus. Humus is organic matter that's found in soil. Okay? So, what we see is that we have more organic content closer to the top horizons of the soil because that is where you're going to have bacteria, you're going to have animals, you're going to have plants. Okay? And what's great about animals is they can help contribute to soil health as well. So, specifically, burrowing animals. So animals that like to dig holes. Okay, so burrowing animals contribute by allowing air and water to move. Okay, so that's really important for soil health as well. Okay, so let's look at soil specifically. There are 3 types of soil particles. 3 types of soil particles. Okay, sand, silt, and clay. Sand, silt, and clay. Those are the 3 types of soil particles. You have to know that. Okay, now this is showing you a size comparison as well. Sand is the largest. If you think about it, you know, when you hold sand in your hand, you can actually see the individual grains. Silt is the next largest, and then we have clay, which is a itty bitty little dot right here. Okay, so sand, if you think about it, do you see like in a desert or at the beach a lot of plant life? You don't, because sand isn't able to hold on to a lot of nutrients and water. So sand has the least nutrients. Clay is going to have the most nutrients. Okay, so when you see these different soil sizes, you know that you're going to have a mixture of them in order for soil to retain enough water to support plant growth. Okay, so the soil particle sizes themselves are going to impact how water is able to flow through it. So it's going to impact what we call porosity and permeability. Okay, those are not the same things. Porosity versus permeability. So this impacts porosity, permeability, and primary productivity. What is primary productivity again? Plant growth. Okay, so over here, this is showing us when we pack these soils together, what do the spaces between the actual soil particles look like? Okay, so this is showing us how the water holding capacity varies by soil type. So this is water holding capacity. Okay. So sand has the largest and most open spaces. So you can understand why water just flows straight through sand. It's not able to retain because the spaces between them are so large. Okay. So this right here has the most open space, meaning it doesn't hold water. Okay, now if you look at clay, it has the least amount of space. There's very tiny little spaces between the soil particles because it can pack together more tightly. So this has the least amount of space. Okay, meaning water cannot get through. So if you just have clay and you put water on it, water literally will just sit on top of it for hundreds of years and not go anywhere. So water cannot get through. So you understand why you have to have a combination when you're trying to grow plant life. You need to have the ability of water to drain through and be retained at the same time. And you have to have soil that has the right amount of nutrients in it. So you have to have a mixture of all three types. Okay. So porosity right here is the amount of open space. Okay, that's the amount of open space. It is not the same thing as permeability. Okay, permeability is the measure of how easily water moves, which is infiltration. Okay, so when we look at agriculture, and the next part of this unit is going to be focused on agriculture. What type of soil do we want for agriculture? Well, we know that loam, what we call loam, is best for farming. Okay, because it is able to have the right amount of water retention and the right amount of nutrients. So This right here is what we call a soil triangle, and you guys are going to have to learn how to read one of these. Now, I'm going to post a separate video that walks you through how to actually read this, but if you look at the sides here, this has the percentage of clay, the percentage of silt, and the percentage of sand, and it's when you get those percentages, it will actually tell you the type of soil that it is. So, for example, if we have a sample of soil that has 40% sand, 40% silt, 20% clay, that is loam, and that's what we know is best for farming. Okay, so you're actually going to do a separate activity over this. It's going to walk you through this step by step. Okay, so we know that soils are composed of varying amounts of sand, silt, and clay. Okay, and that water retention leads to primary productivity. Okay, now, what are some things that actually cause soil to go bad? So what are human impacts on soil? So if you look at this map right here, it shows the global status of human-induced soil degradation. So very high severity. You can see there are quite a few places. Even in the United States, we do have some, like the Midwest right here, the region is high severity of human-induced soil degradation. So what are specific human activities that are causing soil degradation? So the overall categories: deforestation, obviously a huge chunk, overgrazing, agriculture, fuel wood gathering, not so much because it's going to be mostly lower economically developed countries, and then industry is a very small percentage. So when we look at agriculture, we know that part of this is because of overcropping. So think back to history when you learned about the Dust Bowl. We'll talk a little bit about that when we get to agriculture. And also another impact is what we call monocropping. We'll talk about this in our agriculture as well. But it's just growing one type of crop over and over and over again is really bad for soil. Now, deforestation, we can also add urbanization into this. So cutting down trees. Oh, that's not how we spell it. Sorry, y'all. Urbanization. Okay. Removing trees for development. And what is important to know, guys? Soil is non-renewable. Okay? Once it is eroded, it is gone. It's just like the same thing as a fossil fuel. So once eroded, it is gone. We cannot get it back. Now, how do we prevent another Dust Bowl from happening? So let's look specifically at the North American prairies. So this is going to be the Midwest. So this is going to be like the middle section of the United States. So this is where we have most of our commercial farming. So how do we prevent another Dust Bowl? Well, you have to reduce soil salinity and erosion. And the way they did this is they have snow fences. So they're able to gather all of the snow and that water is able to slowly penetrate the ground so that there's not drought-like conditions. And then we also have a process called contour plowing. We'll talk more about that in agriculture, but it's basically plowing the land in a specific way to prevent erosion. All right, guys, we will pick up with farming as part of our next unit when we are finishing out this unit.